Hey everyone, and welcome. Today we're going to pull back the curtain on something you've probably seen a million times, but maybe never really thought about. The humble fluorescent lamp. It's a little piece of everyday magic, and we're about to figure out exactly how that glow happens.
I mean, really think about it for a second. It's not like an old-school light bulb with a glowing hot wire inside. This is a cool glass tube that just lights up. So what is the secret? What's going on inside that makes it all work?
Okay, so let's start at the very beginning. To understand how it works, we first need to get a handle on what a fluorescent lamp actually is. Let's break down the basic idea.
Whoa, okay, that sounds pretty technical, right? Low-pressure mercury vapor electric lamp. But don't worry, it's simpler than it sounds. All it really means is that it's a sealed tube with a little bit of mercury gas inside. And the keyword, the real secret ingredient here, is fluorescence. That's just a fancy term for material absorbing one type of energy and spitting it back out as another.
So here it is, the whole process in 3 simple steps. This is the big takeaway. First, we zap the mercury vapor with electricity. Second, that excited mercury gives off light, but it's invisible ultraviolet or UV light. And third, this is the magic part, that invisible UV light hits a special powder coating on the inside of the tube, and that is what actually glows with the bright visible light we see. See? It's a clever, indirect way of making light.
Now to really get it, we need to meet all the different parts inside the lamp. Think of it like a play. Each component is a character, and each one has a super specific job to do. So, let's meet the cast. First up, you've got the stage itself, the glass tube. But the most important part isn't the glass, it's that white powdery stuff on the inside. That's the phosphor coating. This stuff is our magic translator. It's what takes that invisible UV energy and transforms it into the light we can actually see. Without it, the lamp would just be a dark tube.
Okay, so at both ends of the tube, we have the electrodes. You can think of these as the starting gates. When you flip the switch, these little guys heat up and start shooting out a stream of electrons. They're what kick off the whole electrical process inside the tube. And now for our star performer, the mercury vapor. Now, we're talking a teeny tiny amount of mercury in each lamp, just a little drop. But when those electrons from the electrodes fly through the tube and smash into the mercury atoms, well, that's when the magic happens. The mercury gets super energized and releases all that powerful, invisible UV radiation.
So you might be asking, how do the electrodes get hot enough to shoot out electrons in the first place? Great question. That's the job of the starter. It's this small but super important little switch that gives the electrodes a quick jolt of power right at the beginning, a kickstart just to preheat them. It's basically the ignition key for the whole lamp.
And finally, we've got the director of this whole operation, the ballast. This thing is the brains of the lamp, and it has 2 really important jobs. First, right after the starter does its thing, the ballast sends a massive surge of high voltage through the tube. This is what gets the electricity to jump across and create an arc. But then, its second job is to immediately throttle back the power, carefully controlling the current so the lamp runs smoothly and safely without burning itself out. Pretty smart, right?
All right, so we've met all the players. Now for the main event. Let's watch the performance and see how all these parts work together in this incredibly fast chain reaction to create that beautiful glow.
Okay, let's run through it one more time, from start to finish. Step 1, you flip the switch. 2, the starter heats up the electrodes at the ends and they start boiling off electrons. 3 and 4, the starter then switches off, which tells the ballast to send a huge voltage spike down the tube, creating an electric arc right through the mercury vapor. 5, that zap of electricity excites the mercury, which instantly releases invisible UV light. And finally 6, the UV light hits that phosphor coating, which absorbs it and immediately begins to glow brightly. And all of that happens in the blink of an eye.
So it's a really clever process, no doubt about it. But hey, no technology is perfect. So what made these lamps so incredibly popular for so long, and what are some of the downsides? Let's get into the pros and cons.
And when you put them side by side with the old-fashioned incandescent bulbs, the advantages just jump out at you. Fluorescent lamps are way more efficient. They turn most of their electricity into light, not wasted heat. And because of that, they last so much longer. We're talking 10, maybe even 20 times longer. So yeah, they cost a little more to buy, but their long life and energy savings made them a total game changer for decades.
But of course, there are some trade-offs. The big one, obviously, is that they contain a tiny amount of toxic mercury, which means you have to be careful about how you get rid of them. They also need that extra gear, the ballast and starter, just to turn on. And yeah, we've all seen it, that classic flicker when they're starting up, or that little delay before they get to full brightness.
So with those pros and cons in the mix, where did this technology really shine? Let's zoom out a bit and connect all this science back to the real world.
And the answer is pretty much everywhere. Because they were so efficient and lasted so long, they were the perfect choice for any place where you needed the lights on for a long time. Think about it. Offices, schools, hospitals, factories, even streetlights. For a huge chunk of the 20th century, this was the technology that lit up our world.
So if you only take away one thing from all of this, let it be this simple conversion. A fluorescent lamp doesn't make light directly from electricity. It's a three-step energy trick. Electrical energy gets converted into invisible UV light, and that UV light gets converted into visible light. And it's all thanks to that amazing phosphor coating.
You know, the fluorescent lamp really was a revolutionary piece of technology. It was a truly bright idea that completely changed the way we live and work. And now, as things like LEDs are taking over, it just makes you wonder, doesn't it? What's the next brilliant innovation that's going to light up our future?